Guys, welcome back to my YouTube channel, and today I'm up with the next question of the top 150 interview questions of LeetCode. So let's get started with the same right away. So today's question is threesome. So we are given an integer array nums and we have to return all the possible triplets, nums of I, j and nums of k such that I is not equal to j, I is not equal to k and j is not equal to k and their sum is always equal to solution. So what does it mean that I not like all of this stuff I not equal to j, I not equal to k, j not equal to k? It means that all the indices are different. The in the indices are different in a triplet. So that's what the notion of this question states. So so as given in the question, we are already having an integer array of nums, and we have to find all the triplets in such a way that the set does not contain uh, like the like in a set we cannot actually duplicate the elements in order to make it a triplet. So suppose you are having minus 1 and plus of 2. So you can't use minus 1 of same index twice in the triplet. That's what it means by saying I not equal to j, I not equal to k. So it means we have to remove this redundant part as of in the array. And also we cannot duplicate our answers in the output array. So it means that every answer existing in the output must be a unique value, right? So let's discuss the algorithm for the same and then moving forward towards the code of the problem. So let's discuss and let's just make a note of this example. Let me take a copy and then a paste over here. Yes, it's not working. So we are given minus 1, 0, 1, 2, minus 1, minus 4, 2, minus 1, minus 1. And my answer to it is minus 1 and minus 1. So minus 1 and 2 and minus 1 comma 0 comma 1. So I indeed mm, that the minus 1 that the two minus 1 existing over here are different because there are two indices where minus 1 is present in this array. So not a thing to worry about. We'll cover all these things. So simply, if I talk about this threesome, like taking a triplet, finding whether the elements present in it are summing up to 0 or not, and individually we cannot use the same element twice or thrice in a triplet. If we are using only one, we can use it only once. That's what the intuition of this problem lies over here. So I think a simple solution to it could be a two-pointer approach, right? A two-pointer approach will work fine because what we are actually trying to achieve over here is a sum of triplets in which all the elements sum up to 0, right? So in order to find such a triplet where sum of elements sum up to 0, so we can probably use the two pointer algorithm for the same. So no issues. So let's discuss the approach for the same. Now let's get started with the two pointer approach. I think most of you have already done a two sum question before coming up to this question. I'm assuming it. If you've not done, not a thing to worry, we'll discuss over here. But let's discuss the two sum question before moving forward to this question. So, uh, why I am discussing the preliminary question of this question, because that will actually help you build an understanding to basically how to solve such problems. So let's discuss first the problem of this problem, that is the two sum. So we are having an array like this only. Let me just make a note, and I have to find all the pairs in this array in such a way that they sum up to 0, that my nums of I plus nums of j equals to 0. That's what the intuition of this question is. Although this question could also be solved using hash map, but in this approach I'll not be discussing that approach, because that is because discussing that approach will tend to move this question towards some another direction. Rather, I will try to implement a two pointer approach on this nums array, which will actually help to build your understanding for the threesome. That's threesome question. So let's get started. So for this two sum question, what I will do, I'll simply implement my two pointer approach, which actually states that first of all, sort the given array, and then move from then start moving your two pointers I and j from starting and ending respectively. Keep on comparing the sum of these triplets. If it comes out to be 0, just push it in your answer. And if you encounter duplicates while you get your answer, so we do not have to insert the duplicates. We'll just simply keep on skipping those duplicates. Either we will move in the forward direction or we will move in the backward direction. That's what the intent of this two pointer algorithm states. Simple and easy. So what I will do, while so let's discuss the algorithm for this two sum approach using the two pointer. So I'm given two variables I and j. Let me initialize my I to 0 and j to n minus 1, and I'll simply traverse from my I till j. Let me clarify this example over here, and I'll simply push all the possible pairs of twos that I have right now. So my I stands over here and j stands over here. So what I will try to do, I'll try to find out my sum, which is equal to nums of I and nums of j, and I will just simply make a check if my sum equals 0. I'll simply push this sum these two elements, nums of I and nums of j, to my answer dot add, like I'm just using shorthand notation, n of I, n of j. So, and that's what the thing is. And also the main challenge that we will be having right now is to skip the duplicates that we are having. So side by side, whenever we get our answer, we need to make a check that i if my I is nums of I is equal to the next element that we have. I think it has got pretty messy. So nums of I is equal to nums of I plus 1. I'll simply increment my I, and if my nums of j is equal to nums of j minus 1, I'll simply decrement my j. A thing which I have forgot to mention over here right now is that I need to keep a track on the index of my I as well. like my I plus 1 should always be less than n, and my j minus 1, because the last element that I'll be encountering over here is j minus 1, should always be um, should be greater than 0, j minus 1, or else my j minus 1 greater than minus 1. That's what the exact condition lies over. So whenever I get my answer, I have to simply add it and skip that many steps forward wherever I get a duplicate, or that many steps backward. And else, if I don't get my answer, if my sum is greater than 0, it means I have to skip the greater elements, and that's the story, or else I have to skip the smaller elements. This is what an intuitive two-pointer algorithm states. So now let's just change the form of this array, because as I've already told that whenever we are implementing a two-pointer approach, first and the foremost thing that we need to do is to sort our array minus 1, minus 1, 0, 1, 2, and then 4. That's what the implementation over here lies. So now let's keep our pointer I and pointer j over here. Now let's check whether the sum 4 minus 1 it's equal to 3. So 3 is greater than 0. So it means I will decrement my j. So minus 1 and 2 they sum up to 1. So 1 is again greater than 0. So I will simply decrement my j over here. So minus 1 and 1 they are adding up to 1. So I got one of my pairs as minus 1 comma 1, and I'll simply insert it in my answer vector. So now let's see that if my I plus 1 is less than n and my nums of I is equal to I plus 1. So that's true. So now I'll increment my I. So now let's check it for j out over there. So since j minus 1 is not equal to j, so we'll keep it as it is. So now let's move forward and check for the sum. So minus 1 and 1, it again turns out to be 0. Oh, sorry, I forgot one more check. So I plus plus. So, okay, that's fine. And now, great, because I've already added this to my answer. I guess I've forgot something. Let me just make a look. Minus 1 and 1. I've incremented my answer. So now I don't have over here. So my 1 and 0 is not the condition. Okay, so fair enough. Let's move forward. So now I have already got my minus 1 and 1. So this is also one of the possible answers that we can assume to have. So I guess maybe I forgot something, that in this case I can't actually add duplicates. I am actually adding duplicates over here. So minus 1 and 1, it again turns out to be 0. So again the same story. I guess I have to increment my I and j one more time if I don't fulfill this condition. Okay, that's why. It's because at that point what we are doing is we are actually adding our I and j. So my I goes over here and j also goes over here. I and j, both of them are at equal positions. Yeah, that's what the condition was missing over here. That's why I was saying that why I'm adding the duplicates. because I've not incremented my I and decremented my j at the same time, because whenever we are not getting any duplicates. But at the same time, what is happening over here is we have already added both of these elements in the array, but while adding these elements, we have to actually skip them out right now. Because suppose if I would be having something like 0 over here, so I should have skipped over here and I have to reach over here. That's what the intent lies in the question. So I think that was the only step that I was missing right now. So I have to, now my I and j, both of them are equal. I'll simply escape my loop and I'll return my answer to be minus 1 comma 1. That's my answer, and that's the whole intent of the two pointer approach. So I guess after discussing this two sum approach for the same, we can simply jump to the three sum approach. Why so? Why I'm saying this with such a confidence? Because in that case, what we are actually doing, we are actually adding one more parameter nums of k. That is the third. So while adding this third element, we can actually keep it as a constant value, right? Rather than just blindly moving all the elements together. So what we can do is we can simply pass this constant value in my function to pointer, which will actually get added to my starting, to my I and j every time whenever I'm checking the sum of all the elements. So, and the only line of difference that I could think of is, I think this line of difference might exist over there, but let's see. So that's what the basic intuition of this question is all about. So let's discuss the code for the threesome right now. Why I'm saying for the code? Because what I've done is I've actually made a production ready code already at my end. So now let's discuss the same. So now let's see, because what I did over here is I've simply check, made a check at first instance that whether the I at which I'm standing is equal to its previous. If it's equal, then I'll simply skip that previous element, right? I guess this was the condition that I need to add before in my two pointer, but not a thing to worry. We are discussing over here. So I've made a function two pointer where I've actually passed my I and j, start and end, and I've passed a constant value, that is my nums of k, as the form of int of I. And I'm simply using that approach of two pointer, keeping this nums of I constant while iterating in this while loop. That's what the intent I've already told before. So if I actually get my answer, I will simply push back, or else I have, in this case what I've did is simply implemented my start less than end, because I'm actually using this condition for my while loop. So because in this case there is a great possibility that we get all the elements as equals. Suppose I got all the elements as 1 1 1 1 1 in my array. So do you think that there will actually exist a triplet or a doublet which will actually sum up to 0? No. The answer is no, because all of them, first of all of them are positives and all of them are equal. That's why I've implemented this condition, start is less than end. And I'm simply I'm skipping all the duplicates while I'm working in this while loop, and from the starting while using this nums of start plus plus. And I think if you have got confused, so I can say that rather than, you can also implement this statement in such a way as well, like, it was basically a shorthand notation which I've actually used of start is equal to Norms of start plus 1. So I'm just simply incrementing my start. Okay. Or else if you want we can do start plus plus as well. And same goes for the second statement, but I am actually more or less practiced over this above, so I'm actually using this one. And else if my sum is less than 0, I'm just skipping all the positives, uh, all the smaller values, and moving forward in my array. And if I'm getting my sum is greater than 0, I'm skipping all the greater values from the array behind. Why I'm saying that I'm skipping smaller and the larger values, it is being said on the basis that I have already sorted my array before proceeding with this algorithm. So now let's run this code, and now let's submit it. So I think the code has passed all the test cases and it beats 93.74% of the solutions that are present. So the time complexity of this code turns out to be, first of all, let's discuss it in some detail. The first operation that we did was sorting the array, which is n log n, and then doing the two pointer approach, because we are actually keeping one of the for loops over here. So just keep in mind that we are already having this for loop which is actually going till 0 to n minus 2. So it means there is one factor of n minus 2, and then we are actually moving towards our array every time by half. So it means the overall time complexity of this problem turns out to be n into n minus 2 divided by 2, means near about big O of n square, and the space complexity is big O of 1. Because I'm using the inbuilt sort function, it is actually modifying the input that I'm already given over here. So that's why the space complexity is big O of 1.